Are there any comments, questions, concerns on any of that? I assigned evens and 11 on this section, and I assigned the cryptic quiz. So, evens and 11. Are there any questions there anyone would like me to do? Hearing nothing. It means we all did it fantastically or we didn't do our work. That's always the two options. The evens up to 11 had an answer key. There it was. So if you did them all, you had an opportunity to check them. So there's no questions anyone would like me to do. Going once, twice, thrice. Okay, sold. I will give you the answers to the cryptic quiz then, if you would like. Once Bilal is done sharpening his pencil. Okay, so why does Beethoven now spend all his time erasing music? The answer is he is decomposing, which is a play on words. He was a composer who writes music, but he's dead, so he's rotting, so he's decomposing. So the play there is that he's now uncomposing his music, so he erases it instead of writes it. It's hilarious. What is it called when a seabird lands on a channel marker? That's boy meets gull, and it's not just boy, it's B-U-O-Y, like a buoy. Buoy meets gull. It's funny. And then how does a tree feel after a hard day at work? The answer is bushed. Because it's like a tree, but it's not. It's funny. Okay, cool. Those are the answers to the cryptic quiz. So hearing nothing, there is nobody who wants me to do any of the questions I assigned yesterday. Everyone is either so sure of themselves, hasn't looked at it, or doesn't care. These are the options. Sorry? You don't care? Okay, cool. Here we go. Today, we're going to look at solving with distribution. Based on how these polynomial tests are going, we're going to review a little bit what it means to distribute things, what it looks like when we do distribute, and then I don't think we have any variables to multiply in. If we did, I would definitely need to deal with that, but I don't think we do. So, here we go. When we distribute, because today is all about solving through distribution, I'll review distribution, and there's 4 examples we'll do. When you are distributing, we've got a monomial. Where's your math stuff? What do you mean it's wet? Where is it? So you're leaving it wet in your backpack, as opposed to taking it out so that it could theoretically dry. Take it out. When you distribute, I want you guys to show your work, and it's important to remember that when you've got a monomial times a binomial, you want to multiply that monomial out front. You can take your stuff out of your backpack without talking to anybody. You have to multiply that onto each piece inside the brackets. So 2 times x is 2x, and then 2 times positive 3 is positive 6. The bulk of the issues that I'm noticing on these polynomial tests are when you multiply a variable in. That's where things seem to be going a little squirrely, which you're not going to have to do today. It's all going to be about multiplying in constant terms, monomial numbers, in 2 sets of brackets. One of the things that the first period class was struggling with was showing their work and then just straight up forgetting. So like they'd be like, yes, I have to multiply here and here, and then they'd only do the first one. Maybe it's because it was first period. They were tired. But that was the thing I noticed this morning. So when you're showing your work, make sure you actually do all of the work you're trying to show. When there's a minus sign up front, that's the same as distributing what? A -1. So we're going to multiply that -1 onto each piece inside those brackets. Multiplying a -1 just does what? The only impact it has is, what was that, Faison? You sure? I thought you might have been right. Well, if it's positive, it makes it a negative. If it's negative, it makes it, yeah, negative times negative, which is positive. So it changes the sign when you're just multiplying in a -1. It changes the signs. This one I caught a few of you with on the polynomials test. Matthias Patrifonoi. So a -1 times 2x, -2x. A -1 times a +3 is a -3. That's it. So let's take a look at how this impacts the algebra we've been working on. So every lesson we do is just going to add a new piece to this, and everything we've already done up to this point in this chapter gets brought along for the ride. So we'll do 4 examples. 2 of them I'm going to do twice to show you something interesting. And then I will free you to work. So let's take a look at this first one. These first 2 questions that we're going to do, the 2 and then in brackets y plus 5 equals 16 and -9 equals 3 bracket 2 minus y, have something interesting about them that allows us to solve them kind of 2 different ways. So I'm going to draw a vertical line down through the middle of this box, and I'm going to demonstrate the 2 different ways to solve these first 2 problems. When you've got a monomial multiplying with a binomial, one of the ways to solve these things, the most consistent way to solve these things, is to just distribute what you have into the set of brackets. So I'm going to make sure that these get multiplied in there. 2 times y is what? 2y. 2 times +5 is +10. So 2 times y plus 5 is going to be 2y plus 10. And nothing's happened on the right-hand side. We still have 16 over there. So now if I'm going to solve this thing for y, what's the next thing that has to happen here? Yeah, I want to get y by itself. I want to remove any terms that have no y's in them. So this is +10. I'm going to take away 10 on both sides. Here it's going to cancel, and we're going to get 2y equals what? 16 minus 10 is 6. So now I've got 2y equals 6. When there is no symbol between the two, that means it's being multiplied together. So if I want to undo 2 times y and just get y alone, what do I have to do? And divide by 2. Whatever I do to one side, I've got to do to the other. There it's going to cancel, and we're going to get y equals 6 over 2 is 3. The only new piece here is that we have to distribute first, or so it would seem. Okay, I want you to write out the question again. 2 bracket y plus 5 equals 16. And I want to show you something interesting that happens with this first one. Now, what I'm about to show you only works in several specific cases, this being one of them. So what I've got on here on the left is 2 and in brackets y plus 5. When there is no symbol between a number and the bracket, there's multiplication that's going on in here. Hello, Ms. Cebulski. Do you need someone? Okay. Okay. Now, ultimately what we want to do is we want to solve this thing for y. On the very first day we were looking at this, one of the things I talked to you guys about was this idea of reverse bedmass. So bedmass goes like this. Reverse bedmass goes like this. SAMDEB. SAMDEB. Brackets was the order we do things to simplify an expression, and reverse bedmass was the order we do things to isolate a variable. Now, there is no addition and subtraction outside of that set of brackets. In reverse bedmass, brackets happens last. but we are multiplying by something. When you have a scenario when you're multiplying like this, and this piece on the other side of the equal sign is a multiple of this thing, one of the things you're able to do first is actually divide away the piece that wants to distribute into the brackets. So because 16 is divisible by 2, rather than distribute the 2 in, I can divide both sides by it. If I do that, it's going to cancel here on that left-hand side. And we're just going to be left with the y plus 5. Because we have nothing multiplied out front, we can drop these brackets. And then 16 over 2 is 8. Now we've only got one more step to solve these things. If I've got y plus 5 and I want y alone, I'm going to subtract 5 on both sides. I heard some of you whisper. Left-hand side, that cancels, leaving us with just y, and 8 minus 5 is 3. So we got the same result doing it 2 different ways, which is great. If you're not getting the same result, something's clearly gone terribly, terribly wrong. So this is an option for those of you who feel comfortable doing it. Again, it only works when what you've got is divisible by what you're trying to distribute in. This way will always work, but it might lead you to more work than perhaps you want to do. So this is an option here. Questions about what I've just done? Okay. Let's take a look at this one. This one is the same kind of question. I've got just a value on the right-hand side, -9. And on the right-hand side, I've got, sorry, on the left-hand side. And on the right-hand side, I've got 3 times 2 minus y. This kind of question is exactly the same as the first kind of question, where we've got something to distribute in that could divide out of what we've got on that left-hand side. So this is another one of those kinds of questions where there's 2 ways you can do it. I'll demonstrate both ways. We'll verify that those answers are the same. So first, showing you again, doing distribution again, I'm going to take this 3 and I'm going to multiply it into this set of brackets. I need to make sure it multiplies onto each piece. So that left-hand side is going to stay the same, and the right-hand side is going to become 3 times 2, which is 6, and 3 times negative y, which is negative 3y. Now what's my next step? I want to isolate y. Hassan, why am I subtracting 6? Because I've got a positive 6 here on the right-hand side. So what you were suggesting is that we subtract 6. That is the correct way to go about this. I asked that question in my first period class this morning, and maybe it goes because they're tired, but they gave me the 2 mistakes that students often make, and they gave me the correct option here. What kind of mistakes do you think students make with an expression like this? What kind of mistakes could crop up? Hassan Joe. Sometimes they want to add 9 to both sides. That was not one of the ones that cropped up this morning, but yeah. If you add 9 to both sides, you're bringing things to the variable. You don't want to do that. You want to push things as far away from the variables as you can. Good morning. Nope, good afternoon. Okay, so one of the mistakes that I see, gentlemen, is what Hassan Joe suggested. Sometimes people want to add 9 to both sides. That brings things to the variable, something we want to avoid. Okay, one mistake. What are some other options here? What are some other mistakes you might think students could make on a question like this? Yes, Bilal. Yeah, dividing away the 3 is another mistake I see all the time. When you're isolating for y, you don't get to multiply or divide. Oh, I'll move this back over here. You don't get to deal with the multiplication and division until you've dealt with the addition and subtraction. And in that case, it can be helpful to think about this as reverse BEDMAS. This needs to get dealt with before you deal with the multiplication and division. Fantastic. That is the second mistake I see here. The third mistake is what? Any ideas? Matthias, you look like you're about to put your hand up. No? Okay. It has to do with that sign right there. Yeah. One of the third mistake I see students make all the time with stuff like this is instead of subtracting by 6, students want to add 6. Because they see 6 minus 3y, they want to say, okay, well, I'm going to add 6 to both sides and it's going to cancel. You want to make sure that when you're deciding whether to add or subtract, it's not about the sign that comes after the thing you're getting rid of. It has everything to do with the sign of the object you're trying to remove. Because this 6 is positive, subtracting 6 is what we want to do to get rid of it. Because 6 minus 6 is 0. Okay. Whatever I do to one side, I have to do to the other. Here, those are going to cancel. And negative 9 minus 6 is negative 15. I'm at negative 9, and I'm going down further. 6 equals. Now here I see a whole brand new mistake. What's the mistake? Dropping that minus sign. Regularly, students will just arbitrarily make this thing disappear. They will say, okay, the 6 is gone, so that minus sign doesn't need to continue to be a thing. You have to keep whatever signs are out front. If I have a 6 minus 3y and I got rid of the 6, that negative 3y needs to continue to remain negative 3y. And now I want to get y by itself, so what are we going to do? Awesome, Joe? Divide by negative 3, divide by negative 3. On the right-hand side, now those will cancel, leaving us with something equals y. What is negative 15 divided by negative 3? Positive 5, you bet. Cool. Okay, I'm demonstrating the exact same question with a different first step. So let's write it out again. Negative 9 equals 3 bracket 2 minus y. Okay, so, we okay? Okay. Because I've got a situation where I've got one thing being multiplied by one thing equals, some number on the left-hand side, and the number on the other side is divisible by the thing we're trying to distribute in. An option for a first step is, instead of distributing, what we're allowed to do is divide both sides by this value, just like we did over here. So I'm going to demonstrate that. Instead of distributing it in, let's divide both sides by it. So I'm going to divide both sides by 3. Here what's going to happen is 3 divided by 3 is 1. When we do that, multiplying by 1 doesn't change anything. So I can remove these brackets and I'm going to be left with 2 minus y on the right-hand side. On the left-hand side, negative 9 divided by 3 is? Almost. A negative divided by a positive is going to be negative. And then 9 over 3 is 3. Fantastic. Now, I've got 2 minus y on the right-hand side. We want to deal with the addition and subtraction of this now. I've got a positive 2 here, minus y. So to get rid of the 2, what am I going to have to do? I'm going to subtract 2. What I do to one side, I have to do to the other. And negative 3 minus 2 is negative 5. This is going to be equal to, well, 2 minus 2 is 0. What's left here on the right-hand side? Negative y. Just like before, just because the 2 is gone doesn't mean that negative has disappeared. You have to keep the signs that come before things with the things. So if that's a negative y here, it's got to be a negative y down here. Now, I don't want negative y equals something. I just want y equals something. So how do I get rid of that minus sign? There are 2 ways to do that. Matab. You can multiply by -1. The other way to do it is divide by -1. Multiplying and dividing by a -1 doesn't change the value you have, it just changes the sign out front. So to get rid of that guy, we're going to multiply by -1 on both sides, and we're going to get -5 times -1 is 5, -y times -1 is y, and we get the same value regardless of how we approach the question. Questions about what I've just done? I don't particularly care which way you do this. I want to show you both of them. Pick a way that makes you feel warm and fuzzy inside, or at least less gross, and roll with that. Okay, Abdul, wake up. Or, you know, I don't know what's so funny. But. Okay, 2 more questions. Let's do them both. These ones, you cannot do this way. There is too much going on. Not everything is divisible by the 5. So we have no choice here but to distribute. So let's go ahead and do that. I'm going to make sure that the first thing I do is getting rid of those brackets by distributing that 5 everywhere. 5 times 2n is what? 10n. One of the other things I noticed on this polynomials test that I'm marking is that sometimes when you guys multiplied in, the variables just arbitrarily disappeared. You'd say things like 5 times 2n is 10, and the n is just gone. You got to make sure that each of the pieces that aren't impacted do still come along for the ride. So 5 times 2n is 10n, and 5 times -3 is, well, positive times a negative is a negative. 5 times 3 is 15. I still have that plus 6 on the left-hand side, and nothing's changed on the right-hand side. So now this looks an awful lot like the stuff that we did yesterday. We've got variables on both sides of the equations, and I've got like terms to deal with. So what's the first thing you should do on a question like well, the next thing I guess we should do with a question like this? Get the like terms. What are the like terms? -15 and 6. Again, my C-Block class is taking a bit of a beating today because they demonstrated another one of the most common mistakes that I see at this step. What they wanted to do, they who shall remain nameless, they wanted to gather up the like terms on the other side of the equal sign as well. It's important to remember that that equal sign functions like a wall. You cannot grab things from either side of the equal sign. You got to stay on your own side of the line. So, as Bilal has mentioned, that guy and that guy are going to be our like terms. The 10n is going to stay, and I've got -15 plus 6. -15 plus 6 is, if the arithmetic is bothering you, you will be welcome to use a calculator on this stuff. It is in fact -9. So we got 10n minus 9 equals, and now nothing's changed on the right-hand side. It's still going to be -35 minus 3n. Okay, when we were doing these kinds of questions yesterday with variables on both sides, one of the things I encouraged you was, when possible, leave the variables positive. So if we're going to try and do that, which way should I move the variables? Because they're on both sides here now. Do I want to move them all to the left, or do I want to move them all to the right? Hassanjot suggesting we move them to the left. Why, Hassanjot? Yeah, so I've got positive 10n here. I've got -3n here. To move them over, because these two terms are being, well, subtracted from each other, to undo that, what I'm going to do is I'm going to add 3n to both sides to move all my variables onto the same side of the equation. 10n plus 3n is going to be positive 13n. And so that is the better way to move these things in this question. So I'm going to get 13n minus 9 equals -35. Okay, I've got my n's all on one side, so now let's start moving the values over to the other side. The first thing to move here is the -9. So to do that, I'm going to add 9 to both sides. So I'm going to get 13n equals what? It's -35 plus 9. negative 26. Adding 9s, for whatever reason, adding 9s to negative values regularly screws up students of all grades. I see this all the time. The mistake I see here is that students will be like, yes, it's going to be 1 less than that, so it's going to become negative 30 or negative 24. But if you think about what's happening here, we're at negative 35, we're moving up 9. So moving up is actually going to become less negative. Negative 35 is going to become, moving upwards is going to go negative 34, 33, 32, 31, 30, 29, 28, 27, 26. So 13n equals negative 26. And then the last step here is to divide both sides by 13. Leaving us with n equals, and again, the multiplication, the arithmetic of it all, you are welcome to do on a calculator. Negative 26 divided by 13 is negative 2.
Presents.
Fantastic. I love presents. Presents are just super, super great. I don't have a student by that first name.
I think that's a last name.
Okay. This is a review. I don't want this. No. I want the test that goes along with it. You know what?
You want to make that? You want to make that the test?
No, not particularly.
You have him next block?
I had him first block.
Oh.
Hold on, let me take a look here. Okay, one more example, and then I will free you to work, because you guys are getting restless. Hey, come. Talk to Josh later. One more question, here we go. So what I want to do, we've got multiple things now. I've got a set of brackets here with a 4 in front. I've got subtraction by this whole binomial in brackets. So we're combining a whole bunch of stuff that we looked at the polynomial section, Matthias. And marking those polynomial tests right now is telling me that reviewing this is probably a good idea. So let's take a look at what we've got here. I want to multiply these guys together, this 4 with this binomial, by distributing it on there. And I want to make sure that I subtract this thing properly. When I'm subtracting a binomial in brackets, what you need to do is you need to distribute that subtraction onto each piece inside the binomial. One of the things I was witnessing was just the dropping of these brackets and then only subtracting that first piece. You need to make sure that each piece gets subtracted properly. So let's distribute. 4 times m, 4m. 4 times negative 2, negative 8. Now, I want to subtract this whole binomial properly. So subtracting that binomial properly means I need to distribute the negative sign onto each piece here. It's going to make the first piece a negative m and the second piece a negative 3. When you're subtracting a binomial, you need to subtract each piece. And nothing's happened on the right-hand side, so it's going to be m minus 1. So now we're going to group our like terms. On the left-hand side, what are our like terms? Japrit. What are my like terms on the left-hand side? I'm sick of hearing from House and Joe. We're going to the far side of class now. What are my like terms over here? The 4m and the negative m, you betcha. 4m minus m is going to be? Hello again. Okay, 4m minus m is? Somebody humor me. Yes, thank you. Flashing gang signs, I love it. And then the last piece here, what else is a like term on that left-hand side? Sorry, Matap? The negative 8 and the negative 3. Negative 8 minus 3 is? Negative 11. And nothing's happened on that right-hand side. So now I want to bring all my variables to the same side. Which way should they go? To the left or to the right? Why, Hassan Joe? And so when I bring this guy over, I'm going to have to subtract and 3 minus 1 is going to be positive. So let's do that. Because this m is positive, I need to subtract it to move it over. 3m minus m is 2m minus 11 equals negative 1. Do not drop that minus sign. Now to solve this thing for m, it's the same thing we were doing on day 1. We're going to add 11 to both sides. We're going to get 2m equals negative 1 plus 11 is 10. Divide by 2, divide by 2. M equals 5. You guys are starting to get restless, so we'll speed up the process a little bit. At this stage, it's just the same stuff over and over and over again. For some of us, it's the arithmetic that's impeding you. You want to make sure you're really deliberate about that. If you're second guessing yourself with the addition, subtraction, multiplication, and division, check it on a calculator. If you guys are showing your work and you're organizing your thoughts, you should be fine. It's when students start to get messy that things start to get sloppy and mistakes start to get made. So I'm going to set you to work and then I'll come around and help where needed. Here's what I want you to do. There's a lot, so flip through here with me and I'll show you what I'd like you to do. On this first chunk here, there are 16 questions. I would like you to do 1 to 16 odds. At the end of that, there's an answer key. Flip the page. Find me this guy here. It says pre-algebra assignment on it. This page, I will make optional extra practice. It also has an answer key. Then I've got 3 of these awesome riddles that you guys love so much. The first one with the circles inside the box, optional. Extra practice. The next 2, though, I don't know why this one photocopied weird, but it did. I put it in upside down. What were the headlines after a midget fortune teller escaped from jail? This one is part of your homework. The next one, why do girls like guys who wear shirts with 8 buttons? I want you to do this one as well. And then last but not least, there is this page here, where it says more solving equations. This guy will also be optional. That's everything that'll take you up to the next chapter. Now, so I guess there's technically 6 pages. You only have to do half of them. 1 to 16 odds, and then these 2 riddle pieces here. I will say now, though, any of you who theoretically want to plan to redo the chapter test for this, that's no one's plan to start, but should that be a thing you want to do, anything optional, you've got to show me you've done. So should you finish what is required, optional is certainly not a bad place to go from there. So I'll float around, I'll help where needed, and I'm also going to try and get these tests marked. So if you need a hand, let me know. The whiteboards are free to use for you. The pens are up at the front. On your mark, it said giver. Good luck. Don't forget to check your work as you're going.